Hello guys, welcome to this chapter. Till now we have done in chapter 1 we come across the chemical reactions and the equations, the additional decomposition reaction, double decomposition reactions, displacement reaction and double displacement reactions. In second chapter we have come across acids and bases and salts. In third chapter we learn metals and non-metals, and in this chapter we come to learn the carbon and its compound. Carbon and its compound, and mainly we come across the things are that carbon have in every form. That what are these? Food, clothes, and so many things are there. It has a versatility of an elements used. The medicines, the books. When we burn the food, when it blackened, it is what? It is a carbon form. The fuel, when you check the silencer of a body, which just emission is blackened. It is what? That the higher form of a higher higher amount of carbon is emitting. So when we talk about the bones in the carbon, it is the covalent bond. So while a chemical having the ionic state, it has a high melting and boiling point, but and it conducts electricity in the molten and molten state or in the solution form. So when we come across the certain melting and boiling points, it is given in the table 4.1. So what are they? Acetic acid, chloroform, the ethanoic acid, ethanol, and methane. So acetic acid is known as the ethanoic acid. So here we have why the carbon is using the bonding of an covalent bond, and how it comes from. It can share. It can give. It can. It cannot give the 4 electrons. It cannot gain the 4 electrons. Why? If it gives or gain the 4 electrons, it gets 10 electrons in the total, and it is impossible for an proton, 6 protons, to hold on it, having 4 extra electrons in the shell. So, and to lose the 4 electron, though it is not possible, because the large amount of energy is required to remove the 4 electrons and leaving behind the carbon cation to have 6 protons in its nucleus and holding on just 2 electrons. So the carbons overcome this situation, this problem, by sharing its valence electrons with the other atom of a carbon or with atoms of the other elements. And now it comes to the hydrogen. We're discussing the hydrogen. It has a single bond. Oxygen, it has double bond, and nitrogen, which has triple bond. Right? Hydrogen, one on one, that is double bond. It needs 2 electrons to complete its octet, so it's just making double bond, and the octet is complete. Then it would be 2O2, N2, that is triple bond. NH3, ammonia, the formula is there, that 1 molecule of nitrogen and 3 nitrogen atoms. Methane, it is in a fuel and major component of a biogas and a compressed natural gas. Now, such bonds which are formed by the star sharing of an electron pairs with 2 atoms are known as covalent bonds. Covalent bonds molecules are seen to have strong bonds within the molecules, but intermolecular forces are weak. right? Means when it is bound with the nitrogen atom, it is strong, but while it is with the other atom, it will be weaker bond. So this gives rise to a low melting and boiling point. Allotropes of the carbon. There are different type of allotropes, that is diamond and the graphite. Though the chemical properties of these are same, but the physical properties are changes as per the bonds. As it makes it three-dimensional, it it bonds with the all the four atoms, but in it makes it three bonds in a hexagonal form, right? So diamond, it results to having a different structures, diamond and the graphite, with a very different physical properties, right? So, though the chemical properties are same. So the diamond is the hardest substance known, while the graphite is smooth and slippery. Graphite is a very good conductor of electricity, unlike the other known metals that are studied. Diamonds are also synthesizing in the industries as well by providing in a high pressure and temperature. The synthetic diamonds are very small and otherwise very indistinguishable from the natural diamonds. Then the fullerenes is another form of carbon allotropes, right? Its first one identified was a C60. That means the carbon has 60. That is the structure of a football-like structure. So it's look like in a geodesic dome. So it is by the U.S. architecture, the Buckminster Fuller. So the molecule was named as the fullerenes, but the proper name was given by the scientist as Buckminster fullerenes. The versatility nature of the carbon is that it has a property by which factor it can be the nature of the covalent bond is enabling the carbon to form in a large number of compounds, that is the catenation and the tetravalency, right? So what is the catenation is? The carbon has a unique ability to form in a bonds with the other atoms of a carbon, giving rise to the large molecules, and this property is known as catenation, right? Mark these lines. These compounds may have in a long chain of carbon, branch chain of carbon, and even the carbon atoms arranged in the rings. In addition, we have certain things that carbon atoms may be linked by the single, double, or triple bond. The compounds of the carbon which are linked by only a single bond between the carbon atoms are called saturated carbons, and the compounds which are having double or triple bond between their carbon atoms are called unsaturated carbons. And third, either this capillary of a catenation can extend seen in carbon compounds only. The silicon form compounds with the hydrogen, which is a chain of up to 7 to 8 atoms only. But these compounds are very reactive. The carbon bond is very strong and hence stable. This gives the large amount of compound with many carbon atoms linked in each other. So what is tetravalency? Tetravalency is the capability of linking with the other atoms and form the elements, right? As the carbon has enough valency, so it can share it by making the bonds with the other atoms of a carbon and the atoms of another monovalent elements. The compounds of a carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to the compound with the specific properties which depends upon the element other than the carbon presence in the molecule. Saturation and unsaturation we have described, but the certain thing is the different type of numbers. The numbers increases of the carbon, the name also changes. If the chain has one carbon atom, so it is meth. Ane is for the single bond. Two carbon atom, that is ethane. Eth. Three prop. Four but. Five pent. Six hex. Seven hapt. Eight oct. Nine none. And 10 is for the deck. So Ane is for the single bond. So in this, when we see the structures, it have only a single bond in these, right? Now, now in this we have chain, branches, and the rings. So it is, this is a single chain. This is branched one, right? So having the single chain, we have this. It is completing its octet. This one, 2 by hydrogen, 2 by sharing, 2 by hydrogen, 2 by sharing, 3 by hydrogen, and 1 by sharing. So in this, 3 by hydrogen, 1 by sharing, 3 by sharing, 1 by hydrogen, 3 by hydrogen, 1 by sharing, 3 by hydrogen, 1 by sharing. So this is the cyclohexane. 6 carbons, everyone bonded within a single atom, hexane, but it is in the cyclic form, so that is cyclohexane. Now every carbon atom having the 2 hydrogen atoms and 2 bonds, so it is completing octet by this. That is the ringed chain, branched chain, and this one is simple chain. Now this one is ring. Now it is also a ring, but it has the structure of benzene, having the double bonded alternatively, right? So it's completing 3 by sharing and 1 by hydrogen bond. Okay, so everyone is like this. The formula would be C6H6. Here it is 1 2 2 6 12. So that is C6H12, but in a cyclic form. Now further we have the functional groups. Functional groups are the halogen, that is by the heterogens, that would be a chlorine, bromine, bromine, fluorine, right? Now when a heterogen atoms are by oxygen, then it has in a class of compounds. What are these? Alcohol, aldehydes, ketones, and the carboxylic acids. Alcohols are the single bond OH, single bond C, double bond OH. That aldehyde means other cycle referred by R is just on the one side of this bond. In ketone it is different, that this H is just eliminate from here. Here is other carbon compound chain is linked in it. Here means either side of these compound, ketone compound, have a carbon chain. In carboxylic acid, that this form, it is the ketone form, but the alcohol, this OH is there, and the other side is replaced by the carbon chain, right? That is the way to learn it. Okay, now homologous series. What is that? That the methane cannot be formed methane or methine because it does not have the other carbon. It has a single carbon atom. That's why it can form the functional, and it can only form methanoic. It cannot form ketone. It cannot form aldehyde. Okay, and it can form only alcohol and carboxylic acid and methane. Okay, now when we talk about the structures, there would be a formula that is Cn. N would be the successive number of carbons. Okay, that is 1, 2, 3, 3, and so on. That is the integer, positive integer, 1, 2, 3, 4, 5. So Cn, it is subscript. H2n plus 1, that give the numbers for a simple saturated carbon. But when it is for the ethane, or unsaturated carbon, it is CnH2n, that is for the ethene. But when we talk about ethyne, that is CnH2n minus 2. Okay, now nomenclature. What is the nomenclature is? Nomenclature of an organic compound is the haloalkanes. Alkanes means the normal structure having single bond, but halo means the halogen group is using here, like fluorine, chlorine, bromine. Okay, now the certain prefixes or the suffixes are used in this to define the name of a chemical compound. As in it, we have 3 carbons having a single bond, and the chlorine is added to it, on a one added to a 1 carbon. So it is that prop for 3 carbons, a single bond, but it has chlorine, then it would be a prefix is the chloro. So chloropropane. If it is bromine, that means bromopropane. Comes the second one is alcohol. Alcohols added the suffix ol. As I've told you, the functional group alcohol, it has bond OH. So one hydrogen is replaced and it is ol. OH is added, so propanol. Prop, 3 carbons, A for the single bond, and ol, that alcohol group is added. Aldehyde, that is suffix would be al. And we have discussed that bond C, double bond O on a carbon, and H, and it would be on the either side of the structure, carbon structure. So we include these 3 carbons and give the name prop. Single bonded carbon-carbon bond, so that is A, and the aldehyde group is seen at the last of the structure, that was propanol. Now ketone, its suffix is -1, so that was it is in the center, and I have told you that either side of this bond, this carbon, has the carbon structure, right? So as we have I have told you, so it has double bonded O, so 3 carbons included in this one, so 1, 2, 3. Prop, ane for single, and an is for this structure. Okay, now propanol. Now propanoic acid, 3 carbons having single bond carbon bonds. This structure is called as carboxylic acid. So 3 carbons, prop, single bond between carbons, and ane, and oic is for this functional group. And propanoic acid, alkene, that is 3 carbons, double bond in either of these 2, but we need to satisfy the octet of each carbon. that is propene. Propine is 3 carbons having a triple bond and should have satisfied all the carbons having the octet, completed their octet. So that is prop for 3 carbons, and that any two carbons have share the 3 electrons each. So that is propine and have making the triple bond. Now combustion. Combustion is that any type of allotropic form of carbon burns in the oxygen to give rise to the carbon dioxide along with the heat and light. Like coal, that is the fresh or the pure form of carbon. So C plus O2 give rise to the carbon dioxide and heat and water. Methane with oxygen, it gives rise to carbon dioxide, water and heat and light. So when it produces heat and light, that is, it is a exothermic reaction, right? When we talk about the ethanol, it burns under the oxygen, so it gives rise to the carbon dioxide plus H2. Right. Now here it is, when you use the Bunsen, they adjust the air hole and the base of a different type of flames in the presence of the smoke. What do you get when do you get a yellow sooty flame? Sooty flame, or when do you get a blue flame? That may be August. And the another one is a saturated hydrogen carbon will generally give a clean flame, while unsaturated carbon compounds will give a yellow flame with the amount of a black smoke. Okay, so this results in a sooty deposit on a metal plate. That is for the activity 4.3, but the names were not given. Now, the limiting of a supply of an air results in an incomplete combustion of an even a saturated hydrogen compounds, carbon compounds, giving a sooty flame. The gas kerosene stove have used at homes as inlet of an air, inlet of air, so that sufficiently oxygen rich mixture is burned to give a clean blue flame. If you observe the bottom of a cooking vessel getting blackened, it means that air holes are blocked and fuel is getting wasted. So fuels such as coal and petroleum has a much amount of nitrogen and sulfur in it. Their combustion results in the formation of oxides of the sulfur and the nitrogen, which are major pollutant in the environment. So in the last line, what we have discussed, the sulfur and nitrogen. So which is the major pollutant. So when you goes to the automobile engineering and come across the propulsion or aerospace engineering, there is a combustion in the engines, or the engines you worked on, you will come across the emission. There was in a book, a proper book over it, that alternative fuels can be used, how we can eliminate or reduce the emission of oxides of the sulfur and the nitrogen, and how we can reduce the pollutants from the fuel. Right. Now oxidation. Oxidation is when the alcohols are converted to the carboxylic acids. So the activity 4.5, what is that? We take an ethanol of 3 ml and we give a we warm it gently in a water bath. What is a water bath is? We take a beaker, heat it on the stove, having a tripod in it, and dip the test tube in it, and adding a 5% solution of an alkaline potassium permanganate. Okay, and color of the potassium permanganate gets changes while adding to it. But after a certain level, when it exceeds the limit, it gets get colors get permanent. Okay, so what are these? The alkaline potassium permanganate and acidifies potassium dichromates are the oxidizing alcohol are oxidizing agents. Now, what is the addition reaction? This addition reaction is that mostly used for the unsaturated hydrogen carbons and the hydrogen in the presence of the catalyst, that is palladium or the nickel. Catalysts are present are substances that is cause a reaction to occur or proceed at a different rate without reaction itself being affected. So mark this line. What are the catalysts are? So this reaction is commonly used in a hydrogenation of a vegetable oil using a nickel catalyst, because vegetable oils gently have a long unsaturated carbon chain, while the animal fats have a saturated carbon chains. In some advertisements, you have seen that some vegetable oils are healthy. So animal fats generally contains the saturated fatty acids, which are said to be harmful for the health. So oils containing unsaturated fatty acids should be chosen for cooking. Okay, so substitution reaction. What are the substitution reactions? Now, saturated hydrogen carbons means single bond atoms of the carbon chain that are fairly unreactive, are inert in the presence of most reagents. Now, however, in the presence of sunlight, the alcohol is added to the hydrogen carbon in a very fast reaction. Okay, so chlorine can replace the hydrogen atom one by one. When completely, it can substitute it. It is called the substitution reaction because one type of the atom or the group of atoms take place of another. The number of products are usually formed within a higher homologous of alkanes. Only alkanes, homologous of alkanes are discussed here, not any other form. Not alkenes, not alkynes. The substitution reaction. Now, now it comes to the ethanoic and the ethanol. These are the major, mostly common compounds commercially. Now, the ethanoic is ethanol. Ethanol is liquid at room temperature, while the melting and the boiling points we can have in the table. Ethanol is commonly called alcohol, right? So it is an active ingredient of all alcoholic drinks because it is a good solvent. It is also used in the medicines as well in a tincture iodine, means which is used for the wounds or the scratch on the skin. That is the tincture iodine, cough syrup, and many others. Ethanol is also soluble in water in all proportions. Consumption of all small amount of dilute ethanol causes drunkenness, and even though this practice is condemned, it is socially widespread practices. However, intake of even a small quantity of pure alcohol can be lethal. Right? So lethal means it can be used in the wooden for to prevent it from getting destroyed. Right? All and if it is consumed for a long term in a small amount, it may be hazardous to the health, for it may causes many health problems. So reaction with the sodium. When the ethanol reacts with the sodium, it forms the sodium ethoxide. and leads to the evolution of the hydrogen. And when ethanol reacts with an acid, right, it gives rise to the unsaturated hydrogen carbon. That means the ethene plus water. That is the dehydrating agent which removes water from the ethanol. Now, how the alcohol affects the living beings? It affects uh, that it slow down the metabolic processes and depress the central nerve system. This results in the lack of coordination of the mental confusion, drowsiness, lowering of normal inhibitions, and finally stupor. Means it just uh, play with the mind. It just cut all the coordination of the muscles and your mind. Right? The individual maybe feel relaxed without realizing that his sense of judgment, sense of timing, the muscular coordination has been seriously impaired. Unlike ethanol, intake of methanol is very small quantity can cause death. Methanol is oxidized to the methanol in the liver, and methanol reacts rapidly with the compound of cells, and it coagulates the protoplasm, in which the same way an egg is coagulated by cooking. And methanol also affects the optic nerve of the blindness and causing blindness. Ethanol is important industrial solvent. To prevent the misuse of an ethanol produced for the industrial use, it is made unfit for drinking by adding poisonous substance like methanol to it. Dyes are also added to the color, the alcohol blue, so that can be identified easily. This is called denatured alcohol. Now, property of ethanoic acid. Ethanoic acid is commonly called as acetic acid and belongs to the group of acids called carboxylic acid. 5 to 8% solution of an acetic acid in water is called vinegar. So 5 to 8%, any percent, 5%, 6%, 7%, 8%, any percent is given in the alternatives of the MCQ. You can mark it from 5 to the 8 range of this. The melting point of a pure ethanoic acid is 290 Kelvin, and hence it often freezes during a winter in cold climates. So it gives rise to the name glacial acetic acid. So have you seen in the lab that ethanoic acid is placed on the shelf and it gets a glacial look, means ice was frozen on the top layer or on the walls of the beaker or the container which it's hold. So the group of organic compounds called carboxylic acid are obviously characterized by the acidic nature. Unlike the material acids like HCl, which is completely ionized, so carboxylic acids are weak acids. So that is the answer of an activity 4.7. When dilute acetic acid and dilute hydrochloric acids use the litmus paper and the universal indicators, what are the different and which one is the stronger acid? Now, reactions of an ethanoic acids. What are these? When the ethanoic acid reacts with the alcohol and reacts with the alcohol in the presence of a catalyst, that gives rise to the ester, and these esters are the sweet smelling agents. It can be used for the perfumes and flavoring agents. On the treatment of a sodium hydroxide with an alkali, the ester is converted back to the alcohol and the sodium salt of a carboxylic acid, and this reaction is known as saponification, which is used to prepare of the soap, and the sodium and the potassium salts of a long chain of carboxylic acids, right? So that is that either reactions that when it would be under the ethanoic acid plus ethanol under an acid or a catalyst, and it forms the ester and water. Right, now here it is the reaction with the base. When it reacts with the base, it gives sodium acetate, right? NaOH is a base. While with the carbonate and the hydrogen carbonate it reacts, it gives rise to the salt of sodium acetate, water and carbon dioxide. Now, till now, here is alcohol as fuel. Sugarcane plants are one of the most efficient converters of sunlight into the chemical charge energy. The sugarcane juice can be used to prepare a molasses, which is fermented to give alcohol, that is ethanol. Some countries now use alcohol as an additive in petrol. It is a cleaner fuel which give rise to only carbon dioxide and water and burning it sufficient air. Now this much is enough for today. We are welcoming your comments. If you have any doubts, you can write it or contact it in the if you have any doubts you can write it in the below comments, and your comments will be welcomed. So